Okay, I wanted to do this on the whiteboard that I use, but I can't get it to work right now, so I'm going to try my best to show you how to do this in an Excel spreadsheet. So first of all, we know that we're making bread, and the cost of the bread is $2, and it can be sold for $6. And it shows the probability for the demands. The probability of the demand being 25 loaves is 30%. The probability of the demand being 50 loaves is 25%. And the probability of the demand being 75 loaves is 45%. So the first thing we want to do is find the expected monetary value when baking 25 loaves. So let's just think about it for a second. If I bake 25 loaves and my demand is for 25 loaves, well, how much am I going to make? What is the expected monetary value? Well, the expected monetary value would be how much I'm going to profit from making the 25 loaves. Well, if I bake them and I sell them, and remember, the cost of the bread is $2, and the profit of the bread, or no, what I'm selling it for is $6, then I am making $4 of profit per loaf of bread. So if I sell 25, if I bake it and I sell it, 25 times 4 equals 100. Now, this one is pretty straightforward because if I bake 25 and I have a demand of 50, I have 50 people come in and say they want a loaf of the bread. Well, I can only sell 25. So even if the demand is 50, I can only sell what I have. So I would still make $100. If I had 75 people come in and want a loaf of bread, to buy a loaf of bread, I could still only sell 25, and I would make $4 off of each. So I could only make $100 because I'm only selling 25 loaves because that's all I have. So the expected monetary value, you don't have to really use the probabilities here. The expected monetary value, whether the demand is 25, 50, or 75, the expected monetary value, I'm only going to make $100. So that is how you work the first one. Now, it's a little bit different if you're going to bake 50 loaves. So now we're going to do this scenario, but this time we're going to bake 50 loaves of bread. Now, the demand is 25 here. So I know I'm going to sell 25 times 4 and make 100. But I baked 50. So if I only had 25 come in that day to buy bread, the other 25 I have a loss, or I'm giving the bread away to charity. So I have to subtract this out because this is kind of like I'm losing money here. I'm losing the cost of 25 loaves that I did not sell. So 25 times 2 would be 50. So my expected monetary value here would be, I would make 100 and I'd have a loss of 50. So 100 minus 50 would only be 50. Now here, let's say that I baked 50 and the demand is 50. Well, now we can delete this because I'm going to sell all 50. And each one I'm going to make $4 off of. So I have, in this scenario, I have an expected monetary value of $200. And then on the last scenario, let's say I baked 50 and I have 75 customers come in and want a loaf of bread. Well, I can only sell what I have made. I can't give out bread I haven't made. Since I only made 50 loaves, I will sell those 50 and I will have an expected monetary value here of 200. So now we have to do the probabilities. The probabilities were given in my problem. Here, the probability that this scenario would happen would be 0.30. So we would do 0.30 times the expected monetary value of 50, and we would get $15. Now, the probability of this scenario happening is a 20.25% chance. So we would do 0.25 times 200. So that would be 50. And then on this situation here, there is a 45% chance that this would happen. So, that would be 90. So the expected monetary value would be 15 plus 50 plus 90. So it would be $155. Then what if we made 75 loaves? Well, if we baked 75 loaves, this will be a little bit different. So if we bake 75 loaves, that means we're going to make, and the demand is only 25. Well, we're going to sell the 25 loaves of bread, and then we're going to have 50 that we don't sell. So 25 times 44 is 100. 50 times the cost of those, that would be $100. So we made $100, but we made too much, and that cost us $100. So the expected monetary value here would be 0. And 0.30 times 0 would be 0. Okay, if let's say we bake 75 loaves and the demand is only 50, well, we would sell that 50 and make $200. But there's 25 loaves that we did not sell. So 25 times the cost means we lost $50 because we made too many. So 200 minus 50 would be 150, and then 0.25 times 150 is 37.50. And then on the last one, the demand is 75 loaves, and we baked 75 loaves. So we will sell all 75, and 75 times 4 is 300. So the expected monetary value here is 300, and 45 times 300 would be 135. So if you add all of these up, 37.50 plus 135 plus 0, I can't remember what I got, 172.50. So which one has the highest expected monetary value? This scenario here. So we would be better off to bake 75 loaves. Even if we don't sell all the 75, we will come out better if we bake the 75. So you're always looking for that higher expected monetary value. Now, there is a homework problem I worked earlier where this ended up being a negative number. And if it is negative, you would do 0.30 times the negative number, and you would get a negative number here. So you would leave it as a negative and do the negative amount plus the positive plus the positive. or either just subtract the number from the positive numbers. But you can get a negative expected monetary value here.